Okay, welcome to the next topic in Junior Cert Science Physics. So what we're going to be looking at here is the topic of forces or force. Okay, as always, follow along with the video, guys. I'll tell you what to take down. This will most likely be, excuse me, a two-part video because there's quite a lot in this. Okay, it's a very long topic. Okay, so quite a few new concepts, a little bit of maths, not anything major. It's a good bit of theory in this, okay? So hopefully you can get the grasp with it very quickly. So I'll try and keep the video to 20 minutes in length, in which case I'll stop it and we'll do part 2 then afterwards, okay? So pause it everywhere. Don't try and write as I speak over the PowerPoint. It won't be able to do it. Pause it and write up whatever I tell you to write up, okay? All right, so obviously take down the heading, and then first things first, your learning intentions, okay? So let's take down our learning intentions. So what are they? You will be able to explain what a force is and how to measure it. So you'll be able to explain what exactly is a force, what do we mean by a force, and how would we measure a force, okay? You will understand the effects of balanced and unbalanced forces. What do we mean by a balanced and an unbalanced force? You will become aware of friction and its uses, okay? So you've heard of friction burns and things like that, but what exactly is friction and what do we use it for? How do we use it? Why is it an advantage to have it? And then, of course, we will learn how forces affect the elasticity of a spring, okay? As well as a few maths calculations there. Some extra keywords now that we're going to get are balanced. So again, take down all the learning intentions, take down all the keywords: forces, friction, weight, and of course acceleration. So we've done acceleration already, so you should know that one, okay? But we put it in here anyway because there are keywords in this topic. All right, okay. All right, let's move on to the first thing. What do we mean by a force? Okay, so your heading there is simply, what do we mean by a force? Okay, so if I push or pull a door, have I applied a force onto the door? Okay, so generally what we say, the definition of a force is as follows, okay? A force is anything that will cause the velocity of an object to change, i.e. speed up or slow down. That's a force, okay? So if you kick a ball, you apply a force to the ball. It causes the object, i.e. the ball, to speed up. And if you're on goals and you catch the ball, okay, you've applied a force to the ball because you slowed down the ball, you stopped it, okay? So, and again, of course, here, what we mean by to change the velocity of an object, we mean to accelerate it, all right? So you can also say a force is anything that causes an object to accelerate, okay? So there's two different ways to say that definition there. So just take down the middle point. A force is anything that will cause velocity of an object to speed up or slow down, okay? All right, so keep going, the same heading, all right? So again, that's the same definition, so just slightly different. So take down that version as well, okay? So there's two versions. A force causes anything to speed up or slow down, change velocity or accelerate, okay? Either one, whichever you think is easiest to actually go with that one, okay? And then of course, if it slows down, we call it deceleration. This is just a bit of recap on what we covered whenever we did the last video, speed, distance, and acceleration, okay? All right, so our next subheading, measuring forces. Okay, so what you have here on the left are Newton balances, Newton meters. Okay, they're small ones. All right, we have larger ones as well. All right, so forces can be measured using a spring balance. That's kind of what we have over here. Okay, a spring balance. The greater the force, the more the string is stretched. Okay, you can also measure using a Newton meter. Okay, so there's two different ways. All right, so take down those 2 points. Forces can be measured using a spring balance, or they can be measured using a Newton meter, okay? And of course, the SI unit of a force must be newtons. So all forces are in newtons, a capital N, because it's named after Isaac Newton. Okay, so there are the 3 points I want you to take down there. Forces are measured using a spring balance, as well as Newton meters. And of course, the SI unit is the Newton, hence why it's called a Newton meter, okay? All right, so your next heading there, guys, simply is going to be a balanced and an unbalanced force, okay? Geez, that's a very unstraight line. Balanced and unbalanced forces, okay? So we have here, that's your heading. Don't take on anything else from here, all right? So we're going to look at the picture here, okay? So I went through those topics pretty quick. They were fairly straightforward stuff. All right, so we have an unbalanced and a balanced force here, okay? So the top one is we have two sets of kids, and both of them are pulling at 300 newtons, and then the bottom one, the group on the left, are pulling with 400 newtons, and the group on the right only 300 newtons. And the question is, which is balanced and which is unbalanced? And can you explain why? Okay, so this is balanced. How do we know it's balanced? Well, because they're both the same, you see. 300 equals 300, so it's balanced. So because it's balanced, nothing's going to happen. Okay, they're unable to pull each other. One team is unable to win. But then we look down here. Okay, now unbalanced. You see, this group are greater than the group on the right. So it's unbalanced because one force is greater. Okay, so of course that team then pull the team on the left win because they pull the team on the right over. That's what we mean by balanced and unbalanced. You see. Now, see, keep the heading. For forces, it is important to remember a certain law. Okay. All right. So take down the middle bit here. This is what I always say to you guys. For every action, there is an equal but opposite reaction. Okay? So for every action, there is an equal but opposite reaction. Right? So for everything that goes forward, something has to go back. All right? And then our example here will be this next point down below. Okay? This means when you push open a door or the door is actually resisting and pushes back at you. So when you're trying to open the door, you're opening the door out. The door is trying to resist you. Or if you open the door in, so you grab the door and open it in towards you. The reason you can feel the door pull on you is because the door is trying to stop. The door is going in the opposite direction. It's trying to stop you from opening it. Okay, it's an equal but opposite reaction. It's trying to go the opposite way. It's trying to close. Okay. All right. So take down those 2 points. So why does the door open? Okay. So the question is, well, hang on a minute. If the door is equal but opposite, why is it that we can still open it? Well, because we can apply a greater force on the door than the door can apply back. Thus, we have created an unbalanced force and the door moves. Okay, oops, I accidentally rubbed that out. All right, so take down that point. All right, because we can apply a greater force on the door. All right, so we can apply a greater force on the door than the door can apply back on us. We have created an unbalanced force and the door moves. And that's basically pretty much everything. Okay, so for example, if anyone here does weightlifting, you lift a very, very heavy weight. Okay, you lift it up off the ground. The weight wants to get back down to the ground. Okay, so it's going to resist you holding it up. Okay, and eventually it will get back down. Your arms will get tired. Why? Because it will be able to overweight. Its force overcomes you, basically. Okay, it's an unbalanced force. All right, so you create an unbalanced force. The door, you open the door is trying to push back against you, stop you from opening it. But of course, we can overpower it. We can create an unbalance, and then it of course opens. Okay. So how do we define it? Right, so there's 2 definitions here. So they're all still under the same heading. That's the first definition here. Balanced is when the net force acting on an object equals 0. Thus, there is no change in velocity. Okay, so balanced, net force equals 0, no change in velocity. They're the key words for that definition. Take down the whole thing, but underline those key ones. Balanced, net force equals 0, no change in velocity. Okay, so in other words, that nothing speeding up. Note here, no change of velocity doesn't mean you're standing still. It just simply means that you're not speeding up or slowing down. You could be still traveling at a constant speed, you see. All right, that's something that a lot of people forget. We're not saying your speed, we're saying your velocity. You see? So you're not speeding up or slowing down. Okay. Unbalanced. All right, so unbalanced then. Net force not equal 0. Change in velocity. You see, so the difference. So balanced, so again, every action equal but opposite. So if balanced means there is net force is 0 and there's no change in velocity, unbalanced means the net force could not be 0 and there is a change in velocity. Okay, so every action equal but opposite. Does that make sense? So there are your 2. Take them down. Take down the 2 points and highlight the bits I have there. All right, so balanced, net force equals 0, no change in velocity. Newton's law says there has to be equal but opposite, so therefore unbalanced has to be the opposite, where the net force is not 0 and there is a change in velocity. Okay, so I have 1, 2, 3 questions. So we look at the questions here now, and then I'll go through them with you as well. Okay. Excuse me. So, if a car is traveling east at 50 newtons and the air resistance is going against the car at a force of 30 newtons, is the net force balanced or unbalanced? So, oh, excuse me. Something caught in the throat there. Right, so let me see. Let me change the color of this so we can see. You won't see black. Yeah, so I'll do. Yeah, okay, we'll do blue. Right. So we have a car. So there's our car, and our car is traveling. Actually, you can't really see blue, can you? Right, so we'll do that. We'll change that color to something white. Okay, right. So we have our car, okay, and our car is traveling at 50 newtons, okay, and it's going east, so north, south, east, and west. Okay, so it's going east 50 newtons. Okay, and the air resistance is going against the car at a force of 30 newtons. So air resistance is coming this way at 30 newtons. Okay, so is the force balanced or unbalanced? Well, what we said before, you see here, is we said the net force equals 0 if it's balanced. Okay, so what does that mean? That means what you do is you subtract your two numbers. 50 minus 30 equals 20 newtons. So subtract your two numbers. Is our number 0? No. Okay? So because we don't have a 0, that means it has to be unbalanced. Okay? Because the net force does not equal 0, you see? So we have 50 minus 30 gave us 20. So therefore, the net force is not 0. So what would this be? This would be unbalanced. Do you understand? So sometimes it helps draw the little diagram. Okay, so our car is moving 50 newtons east. The wind is blowing against it with a force of 30 newtons. Is it balanced or unbalanced? Well, you subtract your two numbers. That's all you do. Subtract your two numbers. Okay. If you get a 0, if the two numbers subtracting each other equals 0, you have a balanced force. If they do not equal 0, it is unbalanced. That's it. That's all you have to do. Okay, for that question like that. All right. So let's look at the next question. You don't need to take down the question, guys. Just try and think about it if you can. All right. So let's look at the next question. A car is driving forward with a force of 40 newtons, while the air resistance is going against the car at 50 newtons. All right, let me get rid of this picture here. This picture. Delete. There we go. Okay. So a car is driving forward with a force of 40 newtons, while the air resistance is going against the car at 50 newtons. Is the net force balanced or unbalanced, and what is happening to the car? Okay, so there's two questions here. So we're going to focus on, always with these things, guys, one question at a time. We'll start with the first question. Is it balanced or unbalanced? Now, it's fairly obvious what the answer is, but still, we have to figure it out. Do your maths. Show your maths. Okay, so we have a car, and the car is traveling forward with 40. I'm going to have to get a new Apple Pen. This one's very bad. $40 newtons. Okay, and the breeze is coming against us with 50 newtons. Okay, so 40 minus 50 equals minus 10 newtons. So it's not 0. This does not equal 0. Okay, so because it doesn't equal 0, what do we say? It's unbalanced. Okay, generally rule of thumb, if the two numbers aren't the same, if these two numbers aren't the same, it's obviously going to be unbalanced. Okay, so that's the first part. It's unbalanced. That's our first answer there. Okay, now the second question. All right, what is happening to the car? So what is happening to the car here? Right, so what we say here, all right, is it the air resistance? So the air, yeah, this pen is very, very bad. I'm using the back of the pen because it's doing a little work, but it's not as accurate then. Air resistance greater than driving force. Okay, so the air resistance is greater than the driving force because the air resistance is 50, the driving force is 40. So what's going to happen if the air is stronger than the force of the car? Okay, we simply say the car is slowing down. How is the car slowing down? Simple. if the air resistance is greater. So for example, if I put you on, say, a skateboard and I pushed you along the road and the breeze blows against you, what'll happen? Well, if the breeze is strong enough, it'll actually slow you down and stop you. Because if the breeze is blowing behind you, you keep going, you see? So if the breeze is blowing against the car and the breeze is stronger than the force of the car, then that means that the car is actually slowing down. So there you go. That's how you know. So the air resistance is greater than the driving force, car slowing down. Okay? That's all that's happening there. Now we rub this out. And we look at the last question then on this. Okay. So a car is traveling forward with a force of 40 newtons, while the air resistance against the car is also 40 newtons. What is the net force? Is the net force balanced or unbalanced? So a car is traveling forward with a force of 40 newtons, okay? While the air resistance against the car. So, 1 second now, I'm going to see, can I pull this? Here we go. Get that up there. There we go. Right. Give me space. So, again, we take part one. We have a car. It's traveling forward with a force of 40 newtons. And the air resistance is coming against us. I'll put the air resistance in red of 40 newtons. So what's happening? 40 minus 40 equals 0. So, oh, no, that's not it. There we go. Our net force is 0, so we are balanced. You see? So our net force is 0, so we're balanced. So this is a balanced equation. All right? Now, the next question. So the last time we had the air resistance was greater than the car, so the car was slowing down. This time, okay? So this time it's different. So air resistance is equal to driving force. All right? So the air resistance is equal to the driving force. So what's happening to the car? It is traveling at constant speed. In other words, it's not speeding up, it's not slowing down. Okay, so it's not getting faster, it's not getting slower, it's staying at the same speed the whole way. Okay, so if the resistance is equal to the driving force, then you're traveling at the same speed. If the resistance is greater than the driving force, it starts to slow you down. If the resistance is less than the driving force, you start to get faster. You accelerate, if you will. Okay, so that's it. There are your 3 different kind of questions that you can get. If the driving force is bigger than the resistance, you get faster. If the driving force is less than resistance, you're getting slower. And if the driving force is equal to the resistance, you're traveling at the same speed. Okay? Now, okay, so we get friction done, and that should get us just beyond 20 minutes, and we'll stop then. Okay, so friction is your next subheading. All right? So what exactly is friction? How will we define it? Well, friction, guys, is as follows. Friction is a force that opposes the motion between 2 objects in contact. Okay? So friction opposes the motion between 2 objects in contact. So the reason you're able to sit down, the reason you're able to grab your pen and write is because of friction. Okay? Because what's happening when you grab your pen to write, okay, it is opposing the motion. Your fingers are trying to slip the pen out, okay, and friction is stopping it from doing it. When you're walking, okay, the reason if you stand on ice you slip is because there's no friction there to grip you and keep you on the ground, okay. So friction opposes the motion between 2 objects in contact, okay. Again, the rougher the surface, the greater the frictional force, okay. So the rougher the surface, the greater the frictional force, and the smoother the surfaces, the less the frictional force, okay. So the rougher the surface, the more friction there is. That's why if there's ice, they often throw grit down on the ground, not salt, grit, stones and pebbles. What it does is it increases the surface area, makes it rougher, okay? Whereas if it's smooth surfaces, you'll tend to slip and slide, all right? That's why soccer players and things like that wear football studs, is the studs are to grip into the grass to stop them from sliding all over the place, okay? Right, so there you go, take down those 3 points. Then have a look at this. This is a Mythbusters thing where they have is it a massive phone book, and they show you the force of friction between the pages. It's an interesting thing. Have a look at that. All right, so we'll finish up here now. There's 3 more slides, and then we'll leave it at that. We're just hitting 20 minutes there now. So advantages. All right, so you need to take down all three because there are advantages to friction. We could not live without friction, to be fair. Number one, we needed to stop cars, friction between the brakes and the brake pads. Okay. Number two, it allows us to walk between your shoes and the ground, so that if it wasn't for friction, you would not be able to walk. You just slide everywhere. And number three, friction between the car tires and the road allows cars to move. Okay, so that's it. So it's vital. Basically, it allows you to grip things as well. So number four, it allows you to grab things, grip things, hold things. All right. So friction is vital for life, basically. But then, of course, for every action, equal but opposite. So there has to be disadvantages if there are advantages. Okay. Nothing in life is free, as they say. So disadvantages. Well, number one, your shoes will become worn out due to friction. So eventually, over time, your shoes will get worn out. Air friction means fuel used up in cars. So for example, if you're driving somewhere and the breeze is blowing against the car, you'll actually burn more fuel because your car is trying to resist. You have to overcome not just the road, but now the breeze that's pushing against you. And of course, friction burn. Okay. So for example, if any of you have ever slipped on the ground and skidded your hands across the ground or anything like that, you'll get, skid marks, skid burns on your hands from the ground, okay? Blisters and things like that. And also, if you sometimes put on new shoes, walk around in new shoes, you get blisters. That's why. It's the friction rubbing off it, okay? There are, of course, many more. There are just 3 advantages I could think of. If you have any more, by all means, put them in, okay? So the last thing we're going to do for part 1 gets us just under halfway, and 21 minutes. So we're on hitting 21 minutes there now. So we'll finish it up here, okay? How do we reduce friction is your subheading. All right. So how do we reduce friction? All right. So number 1 is lubrication. So anyone who's a history in mechanics or has a bike will know this. Oil is placed on a surface and the oil fills any of the rough areas. This prevents the surfaces from catching each other. All right. So in cars, you have engine oil because there's moving parts. Okay, so if there's moving parts of metal, they're going to rub off each other and erode away. So what you do is you put oil in, and what the oil does is it makes it smooth, so it prevents things from grinding off each other. Same with a bike. Now as well, the oil on a bike also stops the chain from rusting. Okay, it'll stop the chain from rusting as well, keep the elements off. But really the oil in the chain is to allow the metal pieces to move around. Okay, because if there was no oil, the metal pieces would rub off each other, okay, and corrode. Ball bearings. So ball bearings, they are in wheels and things like that. They're small steel balls that are placed between the surfaces. So what they do is that as the object surface moves, they spin as well. And then, of course, they take the pressure off the joints, okay? And then the last one is streamlining. So this, sports athletes do it. You see it now in athletes, soccer players and runners. They wear extremely tight-fitting clothes. And the purpose of that is to stop their clothing from catching in the breeze and slowing them down, okay? If you ever watch... It's a bit off topic, but if you ever watch old soccer games from the 90s, all their jerseys are really, really baggy. So they're really baggy jerseys. They don't do that anymore because obviously the baggier the jersey, the more breeze you catch as you run. Okay, same with runners. All runners wear tight-fitting clothing. Okay, so as when they run, there's less resistance against them. Okay, and where we use it now is in cars. So cars use reduced air friction in the shape. Okay, so the way they design cars is to prevent the wind from hitting them dead on. The old style cars were very box-like. Windows used to be straight up, whereas now the windows are sloped and the front of the cars are sloped. And it's all to force the breeze to blow around with, not to hit the car dead on. Okay, so there are your 3: lubrication, ball bearing, and streamlining. Okay, all right, so that'll be the end of part 1. We'll get part 2 up soon enough, and we'll do that next. Okay, if you have any questions, guys, put it in the comment section or in the comments in the teams, or write them down and ask them during the live class. Okay, all the best.